All right, problem number 23 from the database for section 5.2 is a little tricky. It has a T after it, implying that it's very helpful to use technology in this problem based on the numerous numbers of calculations that have to be done in order to get the final answer. The question is, if 12 randomly selected adult smartphone users are asked if they use their smartphones during meetings or classes when anyone individually using their smartphone in meetings or classes is 62%, what's the probability that at least 9 of those 12 use their smartphones in meetings or classes? This implies the probability that X is greater than or equal to 9. The probability that at least 9 of those 12 use their smartphone in meetings or classes is the probability that X is greater than or equal to 9. That means the probability that 9 of the 12 use them, or the probability of 10 out of the 12 use them, or the probability that 11 out of the 12 use them, or the probability that 12 of the 12 use them. We found out back in chapter 4 with probability, the probability of A or B or C or D, when they're mutually exclusive, which is true here, is the sum of all those probabilities. So we have to add up all 4 of those probabilities. I'm going now to my graphing calculator to show you the calculation for each one of them. You can either do them by hand using the formula, which is NCX times lowercase p to the x power times q to the n minus x power. So for finding the probability that 9 of the 12 use them, we need 12 choose 9. In the math menu, under the probability pull-down menu, option 3 finds combinations. So this is 12 factorial over quantity 12 minus 9 factorial times 9 factorial. I have to get out of that little subscript land to get here to indicate multiplying that by the probability of success, which is 62%, raised to the 9th power. And again, I have to get out of superscript model to now multiply that by the probability of failure that someone doesn't use their smartphone in classes or meetings to the 12 minus 9 power, which of course is 3. Another way to find this probability is to use the probability by Binomial PDF functionality in the calculator. If you push second vars, you'll get to this distribution menu of functions. And it's a bit down there in the list. Go all the way down, you'll see option A is the Binomial PDF. The newer graphing calculators shows you in the list what the syntax is for this function. The first value is n, which is the trials. The next value is p for the probability of success. And the third value is the x value, which is the number of successes. So I have 12 already here and 0.62, but the x value would be 9 to find the probability that 9 of the 12 people use their smartphone in classes or meetings, and it's 62% for any individual one. If I paste that back to the home screen, you'll notice it's the exact same probability we did by hand. So to find the probability that 10 of the 12 use their smartphones in classes or meetings, I'm going to paste the one I did by hand before and change the 9 to 10, and this 9 also to a 10, and then this 3 to the 12 minus 10 power, which is only 2. And you can verify that if you use the binomial probability distribution function that's listed on your calculator, and you change 9 to 10 here, which is obviously a little easier than doing it by hand, you'll see it's the same probability. I've written down these to 5 decimal accuracy, 0.16342 for the first one we did, and 0.07999 for the second one. We still have 2 more. We have to find the probability that 11 of the 12 use their smartphones in meetings or classes, and all 12. So by hand, I would paste this, or do it by hand and start over, and change both of those 10s to 11. This to 12 minus 11, which is 1. Or just use the binomial probability distribution. You can also push alpha 8 to get right into that menu and change this to 11. It's a little easier to just modify the pasted version from the home screen. So that's 0.02373 with 5 decimal accuracy. I'll just push second entry twice to go back to the one by hand and change the 2 11s to a 12 and the 1 to 12 minus 12, which is 0. Both of these 11s will be 12s. And that one right there is a 12 minus 12, which is 0. Notice if I scroll up and paste the nested command and change that 11 to 12, I'll also get the same value. So now if I add up all 4 of those different probabilities, I'll find the probability of at least 9 of them using their smartphones during meetings or classes. So the first one was 0.16342. That's the probability that 9 of the 12 used it, plus 0.07999, the probability that 10 of the 12 used it, plus the probability that 11 of the 12 used it, which was only 0.02373. And lastly, that all 12 of them use it, which is 0.00323. Notice that adds up to 0.27037, and we are asked to round this to 4 decimal accuracy, which is basically 0.2704, or about 27.04 of the time. When you randomly select 12 people, at least 9 of those 12 will use their smartphone, given that 62% of the time an individual user uses it. If we go back to the problem, you'll see that matches with our answer, 0.2704.